Hey, good afternoon, everyone. My name is Raghuram Sripada. I work for Hitachi. I am a senior director engineering here at Hitachi. So I manage the AI and data products group here. I have around 30 years of experience. Before joining Hitachi, I was at Salesforce for 7.5 years, Oracle and BEA systems around 10 years, a bunch of startups before that. So that is broadly about me. So today I am going to discuss one of the burning topics in enterprise AI. So, but before I dive in, I would like to start with this. This verse was written like 3,000 plus years ago. Right? So it says, Ano bhadraha kratovo yantu vishwataha, which means let noble thoughts come to us from every side. So this probably was the first open source philosophy. So this is very relevant to us today when we solve the enterprise AI problems. So what I call the enterprise AI dilemma. So let us jump into this. Hitachi has been at the forefront of open source movement. We started 25 years ago with contributions to the Linux kernel. In 2010, we developed compliance processes, and then we started contributing heavily into some specific areas. Security is one of our major areas because we predominantly cater to customers in regulated industries, so where security is one of the important concerns. So we joined CNCF, we are part of OpenSSF, and then FinOps. So we are a platinum member with Linux Foundation and then a gold member with CNCF. So we work closely with our customers as well as the community across the globe. Now, what we'll cover today is the enterprise dilemma and how it is addressed. So when we talk about sovereign AI in enterprise, this is about ensuring that data is compliant with what the industry is looking for. Now, what is enterprise AI dilemma? So all the businesses today, they want to adopt AI. There's a lot of pressure on the senior execs to quickly switch to AI. AI first enterprise is what everyone is looking for. Even the senior execs, they even made promises to the markets that they are going to pivot to AI first and AI-driven business. There's a lot of pressure on that. Then competitors are shipping AI-centric products or using AI to improve their productivity. So there's a lot of pressure. And then at the same time, the users are looking for ChatGPT or Claude kind of experiences. That is one side. The second side is the compliance. So there are so many regulations. So starting from GDPR or SOX, and then we have the new EU AI data regulations. And India also has our own regulations today. So all of them, they put a lot of restrictions. So with that, the chief security officers of enterprises are not allowing these enterprises to send their data to commercial APIs. That is a major blocker. Enterprises want to move fast on AI track, but there are regulations that are slowing them down. So then there is a lot of regulatory risk. Some of you might have seen recent controversies about not having transparency in selecting candidates. Workday controversy like a month ago, right? So those are the things. So how can these enterprises go back and prove the complete flow, right? Or how the decision was taken? That is one of the challenges. So net, enterprises want the AI superpowers, but they can't surrender their crown jewels. What is that? Data. They can't send it. That is where the solution is sovereign AI. So sovereign AI in enterprise context is keeping the data within their secure network and then running the models so that they won't have to send their data to the commercial APIs. So keeping everything on-prem. And then providing the complete audit trail. Can I provide the complete audit trail with explainability? How was this decision taken? That is what is expected. And then no vendor lock-in, and then complete compliance readiness. 2 years ago, it was not easy because the models were not mature. When we started, we were doing with Llama 2, and then we were fine-tuning Alpaca, so it was not ready. In fact, there was no consensus on the APIs. So every model was different, so we had to write wrappers to talk to these models. And then the server or serving environments, they also, the infrastructure also didn't mature. We started with Sheldon Core. Sheldon Core, again, changed their licensing. Then gradually all the serving infrastructure, it matured. For example, KServe, vLLM, and various other offerings. So with that, today, the enterprise AI is production ready. We have much better models. So the open source really stepped up. They created a lot of models, which is almost delivering near commercial performance. And then the deployment is very simple. Then the developer experience and then ops experience has also improved. So all the OSS projects, they really stepped up and then they improved it. So with that, the innovation or the enterprise requirement and compliance, they are not mutually exclusive anymore. So with that, I would like to explain how we used open source. Again, starting with the initial verse I spoke about, we took ideas from everywhere, and then we learned lessons, and then we evolved. So this was the mission given to my team in June 2023. So we were asked to build a GenAI platform where we were supposed to avoid vendor lock-in and then use open source models and then open source stack. We already built some cloud-native services to run on our Kubernetes. So Hitachi had a Hitachi Kubernetes service, so we had that infrastructure. And then provide unified access to all kinds of data. Then finally, offer templates so that the users or the developers can develop. Then finally, one of the important parts of success of any technology these days is democratizing. How do we make all this available to our developers of different kinds of developers? You have citizen developers, basically no-code developers, low-code developers, and pro-code developers. How do we make it available to all of them? That was really given to, that was the mission given to us. We work in the data infrastructure space. So Hitachi is a storage and converged systems company, so the group I am part of. So we build these converged systems. These are used by mission critical applications and then regulated industry where the compliance is a requirement. So this is about our journey. So if you look at a typical Gen AI interaction, if I really super simplify this, this is really what happens. There is a prompt. So a prompt is sent to an LLM, and in between, there are a lot of steps that happen. So what is a prompt? There is a system instruction, there is a user query, and then you have the context. You have some examples, if it is a few short prompting. Then you have the output indicators, in which format you want it, and you also define constraints. Right? That is what is really sent. But when it reaches LLM, or before it reaches LLM, there is a lot that is added to this. What is that? It is context. So you do semantic search. You work with vector databases or knowledge graphs. You work with structured data from various sources. Then you also work on function calling or tool calling, especially with agentic AI. These have become central to this. So this is as simple as that, right? So there's a lot behind this. Now, how do we make this available to larger enterprises? So larger enterprise and then developers, and then how do we make it very simple for enterprises to adopt this? So that is where we get into the details. What really happens behind the scenes? So to make that simple interaction happens, there is a lot that happens. So for example, take your vector databases. You need to first populate vector databases, or you need to create knowledge graphs if you are using GraphRag. So that means a lot of data ingestion happens. So there is a data pipeline. Similarly, you need to provide data access to your agents or your applications. That is what we call the data access part. Then orchestration. How do we orchestrate all these steps that we mentioned? So again, you need frameworks around that. This may be a simple orchestration that you have written, or it may be agentic orchestration. Tools. Then you need to manage the prompts. Prompts are really central to everything that you do within GenAI. So prompts evolve. They have their own life. You need to have the ability to manage prompts independent of your code. Along with that, you need the capabilities to test them, version them, and then make them available to your applications. Then you need the tools for the developers to develop these applications, whether you call them agents or you call them GenAI applications. And then operations. Operations is crucial, especially on-prem. On-prem, the interesting part is, in on-prem installations, you have a set of GPUs, but these are limited GPUs. In cloud, there is elasticity. There is no elasticity in on-prem. So how do you efficiently use these limited GPUs to serve all these requests, serve all these customers or the users. That is really where the XOps comes in. XOps is for DevOps or DevSecOps and MLOps. So increasingly, the DevOps teams are becoming more of the XOps teams. They are taking over everything. So that's where the ability to serve multiple models and then of different types and architectures and optimizing the utilization of the resources, all of them come in. That is where, if you look at the previous diagram, so you can put them into 3 pipelines, what I call the 3 pipelines of enterprise AI. So that's where we have data pipeline. So data pipeline is really about taking your raw data and then making it AI ready. So that's where cleaning up of your data, transforming it, and then ingesting into various kinds of databases. It may be vector database or it may be knowledge graphs, etc. Then the second one is training. Take the data, use it to train models or fine-tune your models and make them available to the customers or the users. Then finally, inference. Inference is about taking your user requests and then making these user requests or converting that into AI responses. So all the process that I mentioned in the previous slide, this is achieved here through inference. So these are the 3 pipelines. But the enterprise challenge is that each of these pipelines have a different set of requirements, whether it's compliance or it is security or scaling and operations. Each of them, they move at their own pace, they have their own requirements. How do we manage that? That is where open source comes to our rescue. This is our arsenal. Again, I expanded it a little bit. So we have 3 pipelines, data, training, inference, safety and compliance, platform and operations. Across these, we use different set of tools. So for example, for data, we use different kinds of ingestion frameworks. Vector storage, we use predominantly Quadrant and Milvus. And then we built our own in-house lakehouse. Again, this is a managed lakehouse. Then we use Ceph and Rook with S3, then databases. And then we have training. We standardized on Qflow, MLflow. Then evaluations, we started with Ragas, and then we moved to deep eval. Then for orchestrations, again, we use pipelines. Inference is where a lot of innovation happened over the past 2 years. So we started with Sheldon Core. So we had to move from Sheldon Core to really scale up. So we switched to KServe with vLLM. We also use a Triton inference server. This is from NVIDIA. Then we use LangChain and LangGraph. And then for the rest of the pipelines, we use the message queues and Celery. However, the key part is a lot of additional features that are required for an enterprise AI. That's where we built our own homegrown agent builder. Agent builder allows us to quickly build applications with clicks. That is really to democratize application development. So we made it available to our users. So with this, users can quickly create applications without having any programming knowledge. Then we built an agent runtime. Then MCP has become the standard. So MCP comes with its own security challenges. So we had to create some additional security capabilities. So MCP Authy Broker is one of the features that we built. Then managed lakehouse, then PIA service. PIA is personally identifiable information. So this part is a very crucial aspect of any enterprise. You should not be providing or leaking this PIA information. So that needs to be controlled everywhere, at the time of ingestion, at the time of inference, at the time of even logging. Then finally, operating this whole stack. So that's where serving or improvising your optimization of your GPUs. So we had to create a new Kites app and model operator. This is a lifecycle management. So using which with clicks, the developers that we have can deploy their applications or deploy their models. Because remember, this is on-prem. So we have GPUs, and then the users or the developers, they are deploying models and then applications on-prem. So there is a disconnect. If it is directly Hugging Face, you may take it, but you will have to bridge that. Many times these are air-gapped environments. So for that, we had to create. We, again, for DevOps, we use GitHub Actions and Argo CD. Then for observability, we had to make some enhancements. So observability in these environments, we have the GPUs are all completely under your control. And then the CPUs, network, disk, and then on top of that, your entire kites stack. On top of that, you have applications. So now, in this world, observability means the entire stack, starting from LLM to the GPU. Our ops teams want to see or have the complete visibility from LLM all the way tracing to the GPU. So we had to enhance that. For that, we used OpenTelemetry, we standardized on that, and then we used OpenLLMetry to instrument our LLM chain, and then we use greptimedb. greptimedb is a time series database, and we also contribute to some of these projects. For example, greptimedb, or we had to enhance the OAuth 2 proxy, and then we also contributed to Apache Data Fusion. So we are also a key contributor and maintainers for key clock. So these are some of the things we did. But we are all comfortable with what we call the stack view, right? We are also used to this stack. If I convert the data pipelines into the stack view, this is our stack. So on one side, you have developer tools, then rest of the platform, and then on the other side, the operations, all the tooling that is required. So let me convert this. Just to explain, we have our on-prem hardware. These are converged systems. So Hitachi is also into this business of building and offering these converged systems to our customers. These are GPUs, CPUs, storage, and high-speed network, all of them, so bundled together. So these typically have H100s, H200s bundled together, packed, and again with all the cooling systems and other requirements. So on top of that, we have our Kubernetes, Istio, Knative, and then wherever you see this logo, that is the Hitachi logo on the side, that is what we contributed to, or we built. These are homegrown products. And then the layers below, wherever you don't see that logo, these are all open source. So there is one operator that we built here. Again, that is the model and application lifecycle management operator. Then on top of that, we have KServe, again, vLLM and Triton. And we also use LM cache. LM cache is our, again, KV cache. So KV cache is one of the steps as part of your inference cycle. And then we extensively use RabbitMQ. Unstructured IO is the first library we started using to load different kinds of documents. But now we are also expanding into Dockling, and then we also have Markdown from Microsoft. They recently open sourced. Then we created our own managed lakehouse. Again, it is based on Iceberg, and then we used Data Fusion. Apache Data Fusion is a high-speed SQL engine built completely in Rust. So we built on top of that. Then we use Trino. Then again, as I said, Milvus and Quadrant we use. And then on top of that, we built our own out-of-the-box agents, again, built using our own agent builder. We drink our own champagne. So we built those, and then we created a set of MCP tools for our developers to easily use. And then we are also working on tooling so that developers can quickly get any open source MCP and then deploy it, and then use it as part of their agents. Then manageability agent is one of the agents that the users developed. Then we also created some out-of-the-box solutions. The most important part in this whole thing is that we benefited a lot from open source. Without open source, this would not have been possible. We completely run on-prem, so completely provide flexibility to our developers to develop applications using the framework. And then the agent builder that we built is on top of LangGraph, and then the agent runtime is our version of the LangGraph runtime. So that is what is developed. It is completely based on open source. Now, out of this, some of the major results are, Now today, our developers in different product groups, they have access to this agent builder, they have access to this system, and then using this, they can quickly develop their agents to their products, to support their products. For example, there are certain storage product groups. They are now in the process of building their manageability agents. Now, just to explain some of the lessons we learned from the trenches. We started, again, 2 years ago. So when we started with a few A100s, actually literally 4 A100s. So we were super sure about our architectural decisions. So we spent a lot of time building beautiful homegrown architectures. So we were very confident, and then we spent 6 months perfecting that. Then we thought we were very smart. Then, year 2. But one good thing was that we were able to quickly show some results to our management. The key in this business is that you need to show quick results to your management to get further funding. What is that funding? Get more GPUs. Right? We managed to do that. We got more A100s and added L40s and H100s to our systems. But we also learned lessons. We thought that we were very smart, for example, with observability. Or we thought that our agent framework was very good. But later we realized, oh, LangGraph is doing it better, or OpenLLM is doing it better. Similarly, on the runtime thing, or even the LLM gateway thing, we learned a lot of lessons. And then one of the lessons we learned was that OSS is way, way ahead when it comes to innovation. So we switched to that. So we didn't hesitate to kill our darlings. So darlings were the code that we built and we were proud of. So then one of the things that we learned was that our ego is expensive. Then today, our portfolio or on-prem, we have A100s, L40s, and more H100s are added. So again, we are in acceleration zone. So we see a lot of change that is happening in the industry. So new protocols are being added. So we have we pivoted from 6 months roadmaps to quickly delivering value that the management is looking for. So again, one of the things that we saw was that quick wins are more important than architecture because the market is moving very fast. Your CXOs will come and ask you. And then CFOs are looking for ROI. So are you able to deliver that? And are you able to deliver the value other CXOs are looking for? Are you providing value to your internal developers, whether it is no-code tools or pro-code or low-code tools? Or are you able to support them with a lot of innovation that is happening on models? We keep on getting requests as to whether we could support the new DeepSeek model. Okay, I want to use DeepSeek May 28 version, or the new baby between Qwen and DeepSeek. Can I deploy that? So there is now demand to support various models. We now support that. So with that, our survival guide was to ship MVPs. We actively listened to our customers, the internal customers. We didn't hesitate to kill our darlings, and then we quickly responded to our partners as well as internal customers. With that, thank you very much. I'm open to any questions. I'm also available around. If you have any questions, we are open to do that. And then my team is also eager to participate in any meetups and then share more details, because I covered a lot in 25 minutes. This is all summary. Each of the areas that I spoke about, each of the pipelines, they have their own challenges, a lot of depth. So if you want to learn from us, please feel free to reach to us. Any questions?
So could you maybe elaborate on any specific or the key challenges that you faced during integration of the observability pipelines? Like you spoke about some changes you made in switching from one technology, right? And so what were the motivation behind that? And maybe you can just cover a few points, the key challenges.
Okay, very good. So again, in fact, there is the next session is a very interesting session on observability. They will also cover. They're my my friends, so we work together for some time. But some of the challenges that we faced on observability side is we operate at full stack. So our users, they want a visibility across the stack, which means starting from the agents, so interactions, and then the next level to the platform, all the way till GPUs, and then to the level of even
Hypervisor?
pardon?
A hypervisor?
Yeah. So these are basically kites, so Kubernetes, and below that you have the operating system. Below that, GPUs, disk, including the fans. They actually want how the fans are performing, right? And then how the cooling system is performing. So providing this whole stack was not easy. So you have all disconnected systems. So one of the things we had to do was to standardize. So we switched to open telemetry. And then initially we instrumented a lot of these layers because these systems are coming from different sources. And once we standardized on open telemetry, then initially OpenLLM were not, frameworks were not as mature. Fortunately, these frameworks matured, so we dropped some of our darlings. That's one of the examples I was giving. We dropped our own custom instrumentation and then switched to OpenLLM, that is from Traceloop, and then we integrated it into initially OpenObserve. By the way, that is some story I skipped. We were initially using OpenObserve. OpenObserve changed it to AGPL. Some of our customers, they don't accept AGPL. So we switched to GrepTimeDB. We started contributing to GrepTimeDB as well. GrepTimeDB is our time series database. It uses data fusion and Parquet, where it compresses. And then we push all the data, whether it is logs, traces, and metrics. And then from there, we use it further. Again, we use it for dashboards. We also created agents to talk to this information. You can actually talk to this observability data in English using our agents.
All right. Just one more follow-up question on that. So I've done some case study around AI and observability, so that's why just a little interested into observability. Now, AI and observability basically have to work in conjunction, right? And if I see the top use cases currently that are out there, most of them like IT, infrastructure optimization, right? That is kind of linked with AI and observability, and as you spoke, the challenges on full stack. So when we talk about open telemetry, you know, it just gives you an SDK. And sorry to get into technical details, but how easy was that? Now, so I asked about the challenges. Now, how easy was it to you know, go ahead and integrate open telemetry? Because open telemetry, I think it gives a variation in stack. There's a lot of refinement that you need to do also with open telemetry. So how was that journey like? I mean, you know, switching from that.
Okay, good. So open telemetry or the ecosystem evolved, right? Especially over the past 2 years, we saw a lot of adoption. Just to give an example, so auto instrumentation. A lot of frameworks or a lot of languages or a lot of frameworks, they didn't have auto instrumentation capability. The framework stepped up. That really made it easier. Otherwise, our major problem was the different systems using different standards, then bringing all of them to open telemetry was the first thing. Fortunately, the frameworks also evolved around that, and then we were able to do that. I'll be very happy to discuss further in details. I'm around, and then also please get in touch. We can also participate in any meetups on any of the topics that I mentioned. Any other questions, anyone? Yeah, so, yeah, okay. How did we choose our guardrails?
Yeah, I mean, today, you know, CNCF has many guardrails, like we have K-Gateway, we have envoy-based guardrails, we have Istio.
Right.
So how do you make it very dynamic and, you know, quickly adapt to the customer's use case, if you could elaborate?
Okay, good. So my next speakers are already showing the watch. I'm open to discuss. So one thing that we standardized on was Nemo guardrails, because that's been our trusted framework from day one. So, and then recently we are looking at the other frameworks also. I'll be very happy to discuss offline. I'm around, so we can discuss that.
Sure.
Sure.
Thank you.
Okay. Thank you, everyone.